The global installed capacity of utility-scale battery energy storage systems has witnessed a dramatic expansion over the past 5 years, driven by the increasing demand for renewable energy integration and grid stability solutions. This rapid deployment has, however, been accompanied by several high-profile failure incidents that have garnered significant media attention and raised safety concerns across the energy sector. Despite these challenges, the industry has demonstrated remarkable progress in addressing safety issues, with the global grid-scale BESS failure rate declining by 97% between 2018 and 2023. This substantial reduction can be attributed to the incorporation of lessons learned from early failure incidents into new system designs and best practices. The battery industry continues to engage in extensive research and development activities to enhance prevention and mitigation measures, including developing a deeper understanding of the diverse causes of BESS failures. The Electric Power Research Institute, EPRI, has established the most comprehensive compilation of stationary BESS incidents through its BESS Failure Incident Database, which serves as the primary source for understanding failure patterns and root causes. This database focuses on occurrences that present wider public health and safety risks, rather than operational failures that pose no additional danger to personnel or equipment. As of the current analysis, the database contains 81 incidents from 2011 to the present, with 26 incidents providing sufficient information for detailed classification and root cause analysis. This classification system employs a biaxial framework that categorizes failures by both root cause, design, manufacturing, integration assembly construction, or operation, and failed element, cell/module, controls, or balance of system. This dual approach enables a more nuanced understanding of failure patterns and relationships between different contributing factors. The analysis of classified incidents reveals that integration, assembly and construction emerges as the most common root cause of BESS failures, accounting for approximately 65% of all identified faults. This finding challenges the common assumption that lithium-ion battery cells constitute the primary source of failures. Instead, the balance of system, BOS, and controls systems account for the vast majority of failed components, with cells representing only 11% of classified incidents. The BOS encompasses a wide range of components including DC and AC wiring, HVAC subsystems, safety elements such as fire suppression systems, enclosures, power conversion systems, transformers, and thermal management systems. Recent quality audits indicate that nearly 50% of quality assurance issues occur in the BOS, with 26% of inspected BESS units exhibiting defects in fire suppression systems and 18% showing thermal management system defects. Operational failures constitute the second most common root cause, accounting for approximately 20% of classified incidents. Notably, the bulk of these operational failures occurred during the 2018 to 2019 period when South Korea experienced a significant wave of BESS incidents. Investigation of these failures revealed that a substantial fraction occurred when the state of charge exceeded 90%, suggesting that these failures could potentially be attributed to manufacturing or design issues related to the cells. However, due to insufficient evidence to make definitive determinations, these incidents were classified as operational failures. This highlights a broader challenge in failure analysis. Manufacturing defects often prove difficult to identify conclusively due to the loss of physical evidence after fire or explosion incidents. Design-related failures, while less common, have become increasingly significant in recent years. 3 of the 4 design-related failures in 2023 resulted from the same BOS design flaw affecting BESS products in New York and Idaho, where enclosure design allowed water intrusion into the battery compartment, leading to loss of isolation and subsequent thermal runaway. Manufacturing failures represent the smallest category, likely due to the difficulty in definitively identifying manufacturing defects as root causes post-incident. However, it's worth noting that earlier failures from 2018 to 2020 may have involved cell or module manufacturing defects as contributing factors, as evidenced by several product recalls from major EV manufacturers during that period, citing manufacturing issues by battery OEMs. The timing of failures provides another critical insight. Approximately 72% of failures where system age is known occur during construction, commissioning, or within the first 2 years of operation. This concentration of failures in the early lifecycle phases underscores the critical importance of integration, assembly and construction as a risk mitigation priority. Many of these incidents occur during the commissioning phase when monitoring and communication systems are not yet operational, allowing leaks or isolation failures to escalate into large-scale fires before detection and intervention become possible. South Korea's experience between 2018 and 2019 serves as a compelling case study of rapid deployment without robust safety standards. During this period, 27 of the 30 incidents in the EPRI database occurred in South Korea. The Korean government had provided strong economic incentives for BESS deployment, particularly when paired with solar photovoltaic generation, leading to explosive growth in installed systems from 30 in 2013 to 947 in 2018. This rapid expansion was not accompanied by commensurate development of safety standards and regulations, contributing directly to the wave of failures that followed. The Korean government's subsequent investigation of the first spate of fires and the government's commitment to implementing safety improvements demonstrated how early failures can catalyze industry-wide learning and improvement. The Surprise, Arizona incident in 2019 represents another pivotal moment in BESS safety evolution. This fire and explosion at a BESS facility injured 4 firefighters and prompted the release of multiple root cause investigation reports to the public. The incident marked safety as a priority issue for the energy storage industry in the United States and led to increased scrutiny and safety measures across the sector. The public sharing of investigation details represented a significant step toward greater industry transparency, enabling other operators and manufacturers to learn from the incident and implement preventive measures. The Elkhorn Battery Facility fire in Moss Landing, California, on September 20, 2022, provides a particularly instructive example of dual root causes. The investigation, shared publicly by Tesla, the BESS manufacturer and integrator, and Pacific Gas and Electric, the site owner, revealed that rainwater intrusion through the container had caused electrical arcing within the system, leading to thermal runaway. A water ingress point in the enclosure had been created when an umbrella valve was dislodged during the improper installation of a vent shield. As a confounding factor, insulation loss alarms were not properly escalated to the operator. The industry must continue to engage in regulatory development, voluntary industry efforts, and focused research initiatives to support increased BESS safety and maintain public confidence in this critical energy infrastructure.